And the other presentation was supposed to be by David Hart, who also didn't show up. He had a better excuse because he's in Australia. And this will lead into Bill Hibbard's presentation, actually, because Bill Hibbard's contribution was on open source AGI, why he believes that open source AGI is the best approach to creating AGIs that lead to an ethical alternative for humanity. And what David Hart and I, together with others, and with the sponsorship of the Singularity Institute for AI, are doing is working on a specific open source framework for AGI. And I'm not going to go into a lot of technical details here, which wouldn't be appropriate in the workshop, but we're hoping to launch something in late summer and to provide a set of tools and a framework within which a variety of AGI approaches could be experimented with. The code that we're open sourcing is drawn from the Novamente code base. So we're taking sort of bits and pieces of our Novamente system that we think can serve as a framework for others to experiment with as well. Of course, it's not universal. There's many AGI approaches that wouldn't fit into this framework, and there's many that do. So that we're trying to address issues regarding cognitive architecture, knowledge representation, learning, and then how you teach the system. I'm going to briefly run through those points. Regarding cognitive architecture, we're trying to do something that's fairly neutral and flexible, where you can specify in a configuration file sort of what the main components are, how they connect with each other, what sorts of learning and reasoning algorithms are plugged into each one. So we don't want the open source framework to commit to any one cognitive architecture, although we do have our ideas about that, and we'll supply some standard configuration files sort of inspired by what we've done in Novamente. Knowledge representation is probably the biggest commitment we're making. We're basically open sourcing our Novamente knowledge container, which is something we call the atom table, which is a very efficient container for weighted labeled hypergraphs. So it lets you put different kinds of weights that may represent probabilities, levels of importance, and so forth on nodes and links. You could actually use this to represent a whole bunch of stuff, from attractor neural networks to CRISP or probabilistic logic systems. The most innovative thing in there is a whole bunch of indexes that let you efficiently search things by various quantities like space and time and different kinds of relationship, and a system for automatically building indices that will allow efficient access based on the statistics of the knowledge in there. And it's a real commitment. I mean, not all AGI approaches will work with this kind of knowledge container, but without making this kind of commitment, we really couldn't provide any useful tools. Learning mechanisms is really where it's most open-ended. We're going to throw in simple versions of a couple of Novamente learning mechanisms. The Moses machine learning automated program learning algorithm that Moshe, who was here a little while ago and left, developed, that's already been open sourced, but it's integrated with OpenCog. And a simple version of the probabilistic logic networks module that Matty Clay presented about the other day. But the basic idea of OpenCog is that we would like people to integrate all manner of different learning and reasoning mechanisms in there. We get to see how they play, how they interoperate with each other. Regarding how you teach the system, there's really two approaches that we're going to focus on. Not to say that you couldn't build a theorem prover or do something else based on the framework, but we want to integrate OpenCog with virtual worlds. Maybe Second Life. I think initially we'll have an integration with Multiverse, probably after that OpenSim. If Second Life's planned revamp of their scripting mechanism works as well as they say, we may do Second Life as well. And then we have a rule-based and statistical-based natural language engine called RELX, which we're in the process of open sourcing now, which is not so much an AGI thing. It's a fairly standard in philosophy natural language engine, but it works reasonably well. We'll plug that into OpenCog. That'll be useful for people who want to play around with text processing, natural language conversation, and so forth in the OpenCog framework. And just to wrap up, there's an analogy you can draw, which was due to David Hart, between the operation of an operating system and the operation of a framework like OpenCog. So if you can look at our knowledge container, which we call the atom table, as being somewhat analogous to a file system. That's where information is contained. We have a scheduler which schedules different cognitive operations in the system. That's somewhat analogous to a process or a thread scheduler inside an OS. What we call a mind agent, which is a C++ object representing a reasoning learning algorithm and so forth. A mind agent, it's similar to a daemon or a service in a Unix system. Anyway, We have input-output, so we can load in XML, give out XML, and then we need to be able to export to RDF and various other standard formats as well, similar to the I/O from hardware via device drivers and so on. We have a mini programming language, which is basically a customized variant of Lisp called Combo, which again was Moshe's work. Of course, that's analogous to the numerous programming languages that exist. And you could make more than one programming language to work with OpenCog, but we're giving one to start with. And one of the mind agents that will come initially with OpenCog is a forgetting mind agent, that if you're using the atom table in a way that has importance numbers associated with the nodes and links, the forgetting mind agent will go through and periodically kick the least important things out of memory. That requires that you have an importance updating mind agent that figures out what's important or unimportant. But that's analogous to, although much subtler than, the garbage collection process in an operating system. So to take the OS metaphor, what OpenCog is trying to do is make a framework within which people can make mind agents, which are cognitive algorithms, learning, reasoning, perception, action generation, whatever it is, that run within this framework in much the same way that programs run within an operating system. So the philosophy is, the way things are now is everyone's got to build their own OS as well as the program with it. We want to provide the OS, and then AI researchers can build the programs within it. Of course, the metaphor is stretched a bit because we're making a lot of commitments here, and they just won't agree with everybody's approach to AGI. But when you look at it, an OS makes a lot of commitments too, and Unix is very different than BIOS or Windows and so forth. And in terms of the ethical issues associated with it, whether it's a good thing, if you have really have an approach to AGI that's going to work, do you want to put it out in the open source so that anyone can take it and improve it however they want and do whatever they want with it? It's a very, very hard question. I mean, you have arguments in both directions. There's a great danger there. On the other hand, you get a lot of eyeballs looking at your system to point out potential flaws. And there's obvious dangers in the elitist approach where there's a small group that thinks they have the solution to everything as well. And I don't pretend to know the answer to that. I would note that we're not currently putting all the Novamente secret sauce into OpenCog, but just the basic framework. And this is an issue I've been thinking pretty hard about.